Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Welcome back to the Industrial IoT Spotlight podcast. I'm your host, Eric Walenza, CEO of IoT ONE, the consultancy that specializes in supporting digital transformation of operations and businesses. Our guest today is Rémi Lorrain, chair of the LoRa Alliance operator community and LoRaWAN networks director at Semtech. Semtech is a leading supplier of high-performance analog and mixed-signal semiconductors and advanced algorithms for infrastructure, high-end consumer equipment, and industrial equipment. In this talk, we discuss technical advances that make it possible to deploy LoRaWAN networks globally using next-generation satellites. We also explored the decision criteria for determining when to use a terrestrial LoRaWAN network, a satellite network, or another alternative such as 5G. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, please email us at team@iotone.com. Finally, if you have an IoT research, strategy, or training initiative that you would like to discuss, you can email me directly at erik.walenza@iotone.com. Thank you. Rémi, thank you so much for joining us today.
My pleasure.
So, Rémi, before we kick off and get into this topic, which is a super interesting topic, kind of the future of satellite connectivity for the IoT, I'd like to learn a little bit more about yourself. I think that somehow you've been in this space for almost 2 decades, almost 3 decades now. Could you just share with us, when did you first touch on the topic of IoT connectivity personally?
So sure. Hi, everybody. I'm glad to be here. So 2 topics that are fascinating, I think. So I am Rémi Lorrain. I am from Semtech, in charge of the LoRaWAN operator business development globally and sharing the LoRa Alliance operator community. That's more than 25 years that I've been in the operator market, working for mobile operators. I was initially had a degree in satellite communication, aeronautics and satellite communication, so it's not new. And I've been working for IoT since 2015. I had the opportunity to see the 3 main technologies that are on the market. I mean, cellular IoT, Sigfox, and LoRaWAN. So I think it gives me a kind of overview. And I will not lie when saying that I work now for the best technology. I really believe in it, LoRa and LoRaWAN, and I will explain why.
Okay. Well, you are a champion, certainly, of LoRa. Let's talk a little bit about the organizations you're working for, because you're split a little bit between Semtech and then the LoRa Alliance, which are, of course, very close partners. Can you just share with us a little bit about both of the organizations and then how do they collaborate together?
Semtech is a high-end silicon company since the 70s. Semtech is a leading supplier of high-performance analog and mixed signal semiconductors and advanced algorithms for infrastructure, high-end customers, and industrial equipment. Semtech is just enabling mission-critical application in Internet of Things with LoRa, but not only, also for data centers. Think about the very high capacities fiber optic systems in data center that have been increasing dramatically in the last year with the COVID. And also mobility. We operate on a fiber optic system, 5G long-haul systems, but also on the consumer market. So Semtech is the company that has the patent for LoRa and LRFHSS, that is the LoRa for satellites. This technology is by DNA an ecosystem type of technology. It's what we can name the network effect here. And the LoRa physical layer is linked to a interconnection layer that is named LoRaWAN. It's all about interconnecting end nodes, gateway, network server, so all what you need to make a complete network. The LoRa Alliance of Semtech is one of the founder, was set up in 2015 and today account for more than 400 members in all regions, whatever it is, North America, Asia, Latin America, Middle East, Africa, and Europe. It's growing very fast, and you have both tier one players for all market segments or market type of actors. Can be carrier one operators, cloud companies, or system integrators. And LoRa Alliance is key also to develop, amplify the future of LoRa. And at the LoRa Alliance, I chair the operator community and also the EMEA region.
Okay, great. And when you mentioned that Semtech owns the IP behind LoRa, what is that a protocol? Is it silicon design? What exactly is that intellectual property?
So the intellectual property is about the physical layer that we name the modulation and the chip design. Okay, but since more than 1 year, we sub-license also the technology, for instance, to ST Microelectronics. So it's not the only company, let's say, able to deploy this IP. But yes, it's the physical layer, the radio layer for the specialist.
Got you. Okay, great. And today we're going to be looking at the topic of satellites, which I think is fascinating as an alternative for IoT connectivity. But before we go there, can you just give us a brief on where we sit today in terms of the different applications for LoRaWAN? What are the most typical applications that somebody might see in the field today?
So today, the number one application is utility, water metering, that account for tens of millions units across the world, because LoRaWAN solves the problem that other technologies struggle to solve. I mean, business model flexibility, very, very low power, cost efficiency, and simplicity, while being compliant with security and that kind of stuff. That's clearly the number one use case today, but other use cases are spreading across the world, asset and logistics, for instance. And on the top of that, smart building also is scaling very fast, because with the business model flexibility, the network topology flexibility, LoRaWAN is very easy to deploy on a warehouse or in a building for a business or private company. We see also growing some hybrid business model. I think that cities and communities are keen on LoRaWAN, because you can choose between a operator business model or completely open community or private business model, where you buy one of your infrastructure and you can operate. It's something that it's not easy for with cellular technologies, for instance, that are mainly delivered by cellular operators. Okay, and on the market perspective, LoRaWAN has been increasing dramatically for the last 5 years. We account today for 191 million end nodes. 150 operators use the technology, and analysts like ABI Research anticipate that more than 50% of all non-cellular LP1 connection will feature LoRa in 2026, for instance. So we have a very strong move in all regions, with LoRa being deployed in more than 160 countries, right? But we have something that we lack. Not more than 20% of lands are covered by terrestrial networks today. And most of IoT use cases, because it was your question, require wide coverage. Logistics and transportation, for instance, maritime, asset tracking, or smart agriculture are clearly growing use cases that will require very wide coverage that terrestrial network, but even cellular, are not able to deliver today. Okay? And it's not a surprise that we have 60 plus IoT constellation, yes, 60 plus, that are looking at massive IoT through satellite. And many of them are looking at LoRa.
Okay, so the traditional architecture, would this look like a traditional cellular architecture where you have towers and then you might have some kind of base station in a factory or some kind of other centralized zone, and you would have connectivity within, let's say, a kilometer of that zone? Is that more of the traditional LoRaWAN architecture?
So, in short, we are able to have exactly the same architecture as cellular because, more than 30 cellular operators use also LoRaWAN in the world. So they deploy exactly as such, but we have more possibilities than with cellular. You can also deploy indoor architecture for a mall, for instance, or for a building. And that's one of the reasons why some cellular operators use LoRaWAN, because they think that in some cases, imagine that you have to expand your 4G network to cover IoT use cases. It's not, in many cases, it's not cost efficient. It would be cost efficiency if you have also broadband services in the same building. But most of the time you have only IoT based services. So therefore, the cost efficiency, the simplicity of LoRaWAN will make the difference. Even for cellular operators, it's funny, but it's what we see on the market. So it's not a competition that we have with cellular. It's more a clear complementarity.
Okay, so the cellular operator could offer LoRaWAN as part of their portfolio in order to meet the, let's say, more low power needs. And then, if I understand, a business, let's say a factory or a port, could also buy the infrastructure and basically run their own network if they had enough requirements within that network. Is that also an option here?
That's exactly the case. That's exactly that, in fact. Okay, so you can play with your budget constraints. If you prefer capex or opex, you can make it happen with LoRaWAN with, let's say, tens of different business models.
Okay, great. And now we're looking at this new architecture, which is the satellite architecture. Maybe before we talk about LoRaWAN, let's just touch on what's happening with satellites right now. I mean, I am not an expert in this area at all, but at least my impression, just as somebody outside the industry, is that things didn't change too much for a long period of time. And then all of a sudden, I don't know, maybe 10 years ago, we started seeing really rapid development of infrastructure in space. I don't know if this is accurate. That's just my impression. But how do you view the kind of the market trajectory for the satellites in the past decades?
So in the past decades, what we had carriers operating mainly geostationary satellites for TV broadcast and voice communication. Can be also for mobility for enterprise, providing some what we named at that time fixed link with very large dishes. The evolution of the last 5 years are of two natures. First, it's the first wave of over-the-top internet communication. So people do not yet completely watch the TV through a TV operator. They watch the TV through internet. So they kind of have a workaround or disintermediate the TV operators. And now it came to play that you have to deliver internet and not directly TV program to end users. That's the reason why there is a clear move and pivot into broadband services. You see so many constellations providing broadband services these last years, able to deliver more than 2,000 satellites. The second evolution of satellite is kind of to go toward innovative market because as analysts anticipate billions of massive IoT devices, we see the development of tens of constellation. I counted something like 60 plus projects today just to deploy massive IoT. What is massive IoT? It's quite different from broadband services. These are low throughput, low data rate, and the characteristic it's able to connect devices that are tiny, that should consume very few energy, and may last more than 5 to 10 years in remote areas. So the architecture is pretty different. And what we see growing are what we name low orbit constellation. Two triggers that this constellation have been flourishing. The first trigger is the cost decrease of rockets and launch cost. See what's happening with SpaceX, for instance. And the second trigger of the market was the cost of satellites. Now we see CubeSats of the size of a shoebox that weight like 400 grams. And of course, you imagine that the cost of deployment and operation of the satellite is very low. So it provided the access to startup, and we see a fight between carriers moving to LEO constellation to capture the IoT market and internet market. And at the same time, you see startup, one from the Silicon Valley, for instance, raising funds quickly because the market is easily fund that kind of project and deploy many low-cost constellations. Who will win? We don't know today, but we have to take seriously into account every type of actor. Swarm is one of them, for instance, in the US. Swarm has been able to deploy today so more than 80 satellites. They have a plan of 150 satellites. Imagine that this type of constellation will make them able to cover globally with a few minutes latency. But at the same time, you have EchoStar. EchoStar is a giant, also a US player, but here we talk about the EchoStar Mobile, the subsidiary in Europe of EchoStar. And EchoStar as a carrier is also trying to capture this massive IoT market and will not use the LEO satellite constellation, but leverage their existing high-end geostationary infrastructure to do this. So these are the two nice examples of the market trend: startup and carrier.
Yeah, and it's a bit of a gold rush right now, right? Because the territory is not being licensed out; it's not really owned by anybody. So it's a bit of first come, first serve in terms of territory in the orbits. If I understand, it'd be quite interesting to see how this plays out. What is the architecture then? Is it a direct connection from the satellites down to the device, or is there kind of towers that the satellites are communicating with that are magnifying the signal out to the local devices?
So we have two types of architecture today on the market. One is legacy, that's more than 10 years that operators have been delivering that. It's the gateway to satellites setup. You just put your gateway, your radio gateway somewhere in the desert or on a boat, and you connect your gateway to internet. Instead of doing that through Wi-Fi or 3G or 4G connection, you connect a VSAT connection direct to satellite. Nothing new, but you have to be aware that it's one of the legacy setup of satellites. So I will give you an example. I will cover a mine with sensors able to monitor the worker safety. I will deploy my devices on the factory that can be in the middle of nowhere. Okay. I will concentrate the connection to sensors through a gateway that will be put on the rooftop of a building. And the connection between the gateway and internet will go through a satellite. Okay. That's something that is legacy today. But the new trend of the market, that was your question, I think, it's to connect directly devices to satellites. Because imagine that if I have to monitor a pipeline that is spread across hundreds of kilometers, the range of a gateway is only tens of kilometers, so it will not work. So I have to connect my satellite directly to devices. And here, that's the new architecture. So your device is connected to satellite. Satellites are moving. At one point of time, the satellite is passing over the device. The device will transmit its data to the satellite. Then the satellite is going to move again. It will pass over a ground station, deliver through downlink the data to a ground station somewhere in the world. And this ground station is already connected on Earth to internet and will transmit the signal or the data to an application server. And everything is moving, right? Sensors can be moving. Satellites clearly on LEO constellation are moving very fastly, but the ground station are fixed. Okay, and you have to synchronize. It's not quite easy technically. It's a challenge. You have to synchronize on time all these network parts between the end device, the sensor, the LEO satellite passing over your head, and they have to synchronize emission between device and satellite and ground station. But today, it's a challenge that has been achieved by, let's say, the world technology, and we are happy to see this constellation growing.
I understand now that there's two architectures here, and this more modern architecture allows you to receive data from individual devices. Maybe we can get a bit more into the metrics here, the potential trade-offs. So I imagine there might be, I'm thinking of four. So we have latency, or how quickly can the data be sent and received. We have maybe the bandwidth, so how much data can be effectively sent this way. We have power consumption, or if we have a sensor somewhere, maybe if it's not plugged in, how long can that sensor survive in the field while it's transmitting data to satellites? I assume that actually requires a bit more energy than maybe lower, closer signals. And then lastly, the cost, how the cost might compare to other options. Is there anything else that you would consider to be kind of a critical decision factor aside from those four?
Yes, that's a very good point. Except the geostationary satellite like EchoStar that have no latency, that's the strength of this setup, all LEO constellations have latency. If I deploy 3 satellites, I will have a kind of 6 to 10 hours latency between 2 passes of your satellite, or 2 times I am able to emit data. If I deploy a swarm constellation with close to 100 satellites, it will be a few minute latency. Okay, so latency is the first dimension. In terms of the second KPI could be the payload size. If you look at Swarm has an offering where you can go up to 192 bytes per message. Okay, so it gives you an order of magnitude. The size of the payload is between 50 bytes and, let's say, 200 bytes on the market, so very small in a way. And then you have the data rate that is through hundreds of bits per second. But for some constellation, with a licensed spectrum, you may have increasing data rate that could be up to hundreds of K bits per second. And what is interesting in the data rates, it's the higher the data rate, the shortest time on air. The shortest time on air save your battery lifetime. Okay? If your emission lasts 1 second instead of 5 seconds, you will gain 5 times on your battery lifetime. Okay? And battery lifetime is the first criteria for end customer in massive IoT. You can imagine that if I deploy my device in the middle of the desert or in the mountains in Latin America, I will not go and change my battery every time or every week. It will cost me a lot, right? So that's the reason why, as it is in remote areas, very small sensors, think about your total cost of ownership. You put your device and you hope that you will never intervene on the field.
So coming back to this point of data rate, can you just put that into terms that my mother's going to understand? So what can we actually transfer? What type of useful information can we transfer for 100 bits? What's within scope and what's outside of scope for this type of data rate?
So you will not transmit large amounts of image or file. It can be tricky to do software updates, for instance. it could be tricky to have artificial analytics, artificial intelligence, where you have to send very large amount of data. Most of the time you will transmit the status of a sensor, a temperature value, for instance, pressure value, a measurement of one parameter that can be a humidity for soil monitoring. These are mainly measurements of raw value coming from sensors. Temperature, humidity, pressure, these are some things that you can transmit very, very low number of bytes. Okay? And if you want to transmit a bigger amount of data, you will have to split your transmission between multiple messages. And it will cost your battery lifetime as well. Okay? So it's all about sensors. These are not transmitting image or video. Forget about transmitting video, to make it simple. That's something that I can do with Wi-Fi. I will not be able to do that in massive IoT. Okay? Geofencing. I want to check my worker is not entering a hazardous area in the factory because it's dangerous. He will get in. I have the information that somebody went in a specific area. It's a 0 of a 1 information. Okay?
Yes. Yeah. Clear. Okay. So we're transmitting sensor data. And then you were just going to, I think, get into the topic of costs then. So what are we looking at from a cost perspective? And maybe you can compare this to like a traditional ground-based LoRaWAN architecture.
So there are multiple costs. First, the cost of the sensors itself. The difference between a satellite sensor and a traditional terrestrial sensor are on two sides. First, there is a software upgrade to get LRFHSS, long-range frequency hopping spectrum. For your mother, it's just the LoRaWAN for satellite. So it's no specific cost. And you have to have a good, high-quality antenna design. So maybe you can have an additional cost for antenna design, but it's a very small order of magnitude. So in short, I would say the cost of the device side are comparable to what we see traditionally on a terrestrial network. What you have to add to this cost is what you will have to pay to the satellite operator. Okay? Up to now, the cost of satellite connectivity was higher than the terrestrial network. It can be sometimes X-fold higher. It can be very expensive, but there is a clear value behind, right? Who is able to deploy the network connecting your device, especially for critical application. It made sense for specific safety. Imagine safety in maritime. You don't care about paying because that's the life of people that is here that we talk about. But now with massive IoT, the trend of the market player, I think that we will still see a premium between satellite companies and terrestrial network because there is clearly a value, but you will not have twofold or you will not have a big difference between the pricing model. The order of magnitude will be in a few percent of cost differences. It will not be 2 to 5-fold or 2 to 10-fold like for the legacy system. And over time, the cost differences between satellite and terrestrial will probably decrease because satellite operators may amortize also their infrastructure. And in IoT, there is something that is interesting to understand. You may pay not just for connectivity, because a sensor is not emitting a message every second, right? You may pay only when you send messages. So it will open the way to smart business model as you pay. So imagine if you design your application that is only event-based, you may reduce your number of communication and thus reduce the cost that you have to pay to the satellite company. So massive IoT will trigger, enable some smart business model where the bill will be reasonable for both parts. Okay? I transmit less, I pay less. But the good thing for the satellite company is that they will be able to put more customers on the same infrastructure. So it will be a win-win approach.
Okay, great. And where are we in this today? So this sounds like a very useful addition to the portfolio of connectivity solutions. Is this architecture already active today? Is it mostly in pilot form? Do we have use cases already at scale?
So you have two types of setup today. We talked about Swarm. Swarm is commercially available globally. Okay. And if you go to the website, you will see a data plan, for instance, $5 per month per device. So you have a clear pricing model, you have an offering, and you have customers connected to Swarm. Okay, it's commercial. And you have also many projects. More projects are under test and POC than commercial, to be honest, today, but it's growing. EcoStar, for instance, is currently decided to test LRFHSS, and it's not yet commercial. Okay, so it might be commercial in a few months, but today they are at testing phase. And if you look at the pipeline that we have today, of course, we have tens, the order of magnitude is tens of projects in POC or prototype phase. I could say we observe that the majority of massive IoT satellite projects today are under POC phase.
Okay, clear. Maybe if we look at a couple of the most mature projects, what would be the industries? Are we talking about, you've mentioned a couple, you've mentioned shipping, you've mentioned maybe oil pipelines. What are the areas where markets or industries are furthest along in adopting satellite for IoT?
So we see two types of players. First, the global ones, a tracking company coming to us and say, hey, we would like to connect our trackers, can be car recovery trackers, can be pet trackers, can be safety trackers for mountain activities, but they want to be global, or can be just asset tracking, right? The second type of customer that we have are regional. We have a customer asking for maybe coverage in the US for smart agriculture, or coverage in Latin America for environmental application. They want to anticipate earthquake, for instance, in the whole Latin America region. We have customers willing to monitor oil veil in Middle East and Africa, but that is more regional. We have multiple customers in Europe because it's a growing use case for logistics and asset tracking, willing to have a connectivity across Europe. Because in Europe, we have more than 80 LoRaWAN network operators, and it might be easier for outdoor use case, because we talk here about outdoor use cases, to deal with one satellite company instead of having to set up roaming agreement with 80 countries. Can be also an indirect effect of satellite. It's one interconnection for a large coverage, mainly outdoor. It does not compete at all with indoor coverage provided by terrestrial network, or it does not compete with very dense areas in big cities where satellite will not be the most efficient connectivity. Satellite will be more efficient for rural area, hard to reach areas. So it's a pure complementarity with terrestrial network. And I think they will collaborate through roaming. It's what we see coming also on the market.
Okay, very interesting. Yeah, we have a case. I mean, I'm actually not sure if this is using satellites or traditional cellular, but we have a case right now, which is a company wanting to sell devices into multiple regions, and just the cost and complexity of deciding which SIM card to put into which sensor before you ship it out it's sufficient enough to justify having kind of this type of all-in-one plan, right? There's just on the manufacturing side, quite a savings in terms of complexity reduction and being able to put one chip in and.
Yes, agree. It's a side effect. We were not expecting that some customers choose satellite to simplify interconnection. That's funny to see that because it was not the goal, but it is a clear outcome that we see on the market. I think that it will also accelerate interconnection between terrestrial network. It will put a kind of pressure that terrestrial network maybe will more cooperate into interconnection. That could be a positive outcome. You see what I mean?
Absolutely. So let's say, there's a network that has 150 countries, but they don't have the open seas, right? So, of course, that would be something they'd want to add to their connectivity portfolio. What does network coverage look like from satellites today? Because I guess if we look 20 years ago, it would be heavily centered over big urban areas, maybe let's say wherever satellite dishes for TV are needed. I guess today, is it still, I suppose to some extent, it's unequally distributed around the world. Are there still significant dark spaces or spaces where maybe a satellite only passes over once a day and other places where a satellite's pretty much always over, or are we starting to fill the dark spaces in quite quickly?
So the beauty of low orbit satellite is that now you almost have no blind spot, maybe except in the polar areas where you have to get a specific architecture. But with LEO satellite, consider that every place of the world is covered by the LEO sat, because LEO satellites are circling around the Earth, okay? And there is a kind of delay. After every circle, you delay X degrees, and you start a second circle. To make it simple, after a few hours, every single place of the globe has been covered. You can cover globally with only 3 satellites in LEO. You will just have latency, right? Like I explained, you will have maybe 10 hours latency. But after 10 hours, every point of the globe will have seen the satellite. So with LeoSat, all players will be able to play global. So that's the advantage. So normally, we will have less blind spot like we see with TV, where a geostationary satellite is maybe focused on some region. With massive IoT LEO satellite, it will not be the case.
Okay, fascinating. Yeah, we had a company on a couple months ago called D-Orbit, and they build logistics solutions for managing satellites. So basically deploying satellites, collecting them, making sure they don't crash into each other. I mean, it's really incredible to see the explosion of innovation and complexity in this system. Remy, is there anything that we haven't touched on yet that's important for folks to understand about LoRaWAN through satellite connectivity?
So, important things like in IoT, we believe that standard will help to scale these technologies. I put an S. LoRa today is a de facto standard, and LoRaWAN is reinforcing this standardization process. It's key to that people know that LoRaWAN satellite based on LR FHSS has been endorsed by the LoRa Alliance in December 2020. And I believe that in the next years, the winning players may be the one using terrestrial standard for satellite. I mean, LoRaWAN is a de facto standard on Earth. It will become the same standard for satellite, bridging space and Earth. It's gonna be the same with 5G satellite that is going to connect with terrestrial 5G network. Today, the satellite projects are mainly proprietary. What I see coming, what I see growing, is the use of terrestrial standard to be applied, expanded to satellite. I mean, the 2 leading ones are going to be LoRaWAN and 5G satellite. I think it's a visible trend of the market today.
Is there overlap? I mean, certainly 5G is also meant to be low latency, high bandwidth. Is there significant overlap in the use cases, or are they more complementary?
They are exactly like on Earth, complementary. It's what you observe. If you have to, let's say, to transmit large amount of data, if you need a strong downlink capacity, if you need real-time application, if you need continuity between a cellular 5G network and space, 5G satellite will be the one. If you need a flexible business model, cost-efficient solution, battery consumption is something that is vital for your use case. LoRaWAN is probably the best. And what you will have probably, we will have satellite companies like on Earth operating both, in fact. You put one satellite, and on your satellite, you have one 5G sat payload and one LoRaWAN payload. Okay? Because the biggest cost is the satellite itself. Then you can embed multiple technologies on it with the software-defined radio architectures, for instance.
Okay, fascinating. Well, we are getting ready for a much more connected world. Let's see, Rémi, anything else we should touch on here?
No, that's okay. I was pleased that you asked all these questions, that we could really share the deepness of this market. And you understood that it is instrumental for the development of massive IoT. Remember one KPI, only 20% of the Earth is covered by terrestrial network. So think about that, and let's discuss maybe in 3-6 months, and you will see that satellite will develop.
Yeah, well, this is huge. I always tell people, in IoT, there's two big branches, right? There's the complexity branch, which is doing things that are cutting edge for very sophisticated process manufacturing, digital twin, this type of thing. But then there's the simplicity branch, which is how do we make things cheaper and simpler so that deploying 10,000 sensors costs me a very manageable budget, and it doesn't require much management bandwidth. I can just say, okay, we're going to allocate $100,000. It's going to take a month. We have a project team and we get it done. No problem. And that second branch for me is almost more exciting than the first, right? There's so many things that 10 years ago were extremely expensive and extremely complicated and required a lot of management coordination and technical coordination. And today they're plug and play and they're affordable. And that is, in a lot of cases, that's the most transformational thing, is just making technology simpler to use and more cost effective. And so I could see this being a huge, huge push forward for a lot of things that we've known how to do them. It's just been too cost prohibitive and too complex to do them in the past, right? So this is going to be, really, really an exciting decade ahead. Thanks for coming and sharing this perspective on it.
My pleasure, guys. I come back when you want.
Okay, well, let's definitely do a review in 2 years. I'll be really interested to see where we are then.
Okay.
Thanks for tuning into another edition of the IoT Spotlight podcast. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, please email us at team@iotone.com. Finally, if you have an IoT research, strategy, or training initiative that you would like to discuss, you can email me directly at erik.walenza@iotone.com. Thank you.